Dear students, good evening. Let us see the problems on the control charts for the attributes. We are having two types. One is P chart and C chart. Other one is C chart. P chart is also called as a fraction defective chart. So number of defectives. Okay. The second one is it will be used to find out the fraction defectives. The second one is C chart. So number of defects per unit, particular unit. For example, take a piston. So in the casting operation of piston, we are having number of defects in a particular operation. So like that, we can use these two charts. We are having two limits. So one is upper limit and lower limit. So P bar plus Z sigma P and here P minus Z sigma P. Here we are using the 3 sigma limits. So here the Z value will be 3. So this is for P chart and here this is for C chart. C bar plus Z root of C bar and here we have minus. So here C number of defects by number of samples. So here sigma P will be root of P bar 1 minus P bar by yeah. Let us select problems. See. In a factory, a quality inspector examines 15 samples of size 50 each, 50 each size, sample is 50, and finds defectives as given in table. Okay, you have to find the defectives. Construct an appropriate control chart. Here they are not mentioned in the required chart. So based on the given problem, you have to identify the suitable chart. So here is the number of defectives. So number of defectives. Okay. So based on this is the problem. Sample number. They are given only this blue color table only. This is the number of defectives. Okay. So here the suitable chart is P chart. So here first we have to take the values in this table. So sample number of defectives. You can denote with A. And sample size is given in the question. Sample size 50. Sometimes they will may give as 200, 300 like that also. Okay. Here no need to write here because all the values are same. But sometimes they may give like what is 50, 100, 150 and 180, 200 like that. If it is different, it is better to write it. So the value is same. So you can write on the top like n is equal to 50. It's not an issue. You can follow like either like this or like that. Then you have to find out the fraction defectives. The formula P is equal to A by N. So this is the A value and this is the N value. So 15 by 50, 0.3. 15 by 50. So like that for each value you have to find out these values. Okay. Then you will get these values. 15 by 50, 0.3. Okay. So this is about P chart. Sometimes they may ask find out the values for NP chart and 100 P chart. So if you want to ask it to draw NP chart and 100 chart, then you have to find out NP and 100 value. Here NP, here NP is the N into P values. Hey, stop. Send button to NP. Okay. NP value. So NP. So N into P. 50 into 0.3. Okay. Here NP is similar to A because P is equal to A by N. So NP means A by N into again N. So N and N will be cancelled. We get A only. So this value should be similar to this values. Here 100 into P. So 100 into P. So 0.30, 30, 20 like that. So these two are not required for this problem. But if they ask, we have to find these values. Okay. Here. So after finding the fraction defectives, okay, you have to find the P bar. That means average. You have to take the average. So you have first you have to find out all the values. So total number of defectives C here. So 15 plus 15 plus 14, you have to add all the values. That is 188. So 188. Okay, this is about total number of defectives. Okay, got 188. This is about the average of fraction defectives. That is P bar. So here to find the P bar, see here, P bar 3.76 by total values is 15. Total values is 15. So 3.76 by 15. So you have to add all these values. You have to add all these values. Then you got 3.76. So 3.76 by total values. So this is fraction defective. We need P bar. So that's why we are taking the average of all the values. This step is not required. Okay. Then so we need upper control limit and lower control limit as per the formula. So P plus 3 into sigma P. Yes, sigma P is P bar. We know the P bar values. And n value also. Here n value you have to take sample size. Remember, don't take number of samples. Here n is the sample size, that is 50. Then you get the upper limit and the lower limit. As per the previous procedure, like X and R chart, you have to plot all the points in this. So here you have to take the 15 samples on the x-axis, and you have to take the remaining values on y-bar. So here the maximum value is so 0.43. Let us take 0.5 as the maximum value. Here 0.07. Sometimes this value we may get in negative. In those cases, you have to take that value as 0. Remember, if you get negative value for lower control limit, you have to take the value as 0. So like that, you have to take the scale. Then you have to mark the points here. These points only you have to represent on this graph. For example, the first value for sample number 1, the value will be 0.3. So first value 0.3. Second value also 0.3. Again fourth value 0.3. So third value 0.28. So like that you have to mark all the points. Okay, then you have to check whether the process is in control or not. So see, all are within the control only. So you can write in the comment, all the points are within the control. Then you can say that the process is in within the control. Right? This is about P chart. Then similarly you have to solve the C chart. So one more point before going to C chart. See, sometimes they may ask the problems like this. 20 samples, here the sample 1 to 10 and 11 to 20. Here the sample of size 200 each. They're given the n value is 200. And then see, the results are given a bit phone కట్ చేసి ఫోన్ తీసా తీసుకురా. The results are given in the table book. Calculate the average fraction defective. Calculate the calculate the see average fraction defective and 3 sigma control limits. So in previous formula, see Z sigma P. Z here Z is the 3 because they mentioned 3 sigma control limit. Even though they are not mentioned, you have to take sigma as 3 only. So like that you have to take the sigma value for fraction defective. So calculate the average fraction defective. Average fraction defective means you have to take the average of all the values. Okay, and you have to solve a chart. Here, this is a different problem. See here, sample size was 300 and total samples are 20. These are the different samples. The same procedure you can follow. Sometimes they will give the fraction defectives directly. Number of defectives and fraction defectives also will be given directly. Then you don't need to calculate. Okay, if they're not given fraction defective, you can use this formula. Okay, this is about P chart. Let us see C chart. The total number of defects in a casting operation per making piston. So number of defects in casting operation per particular unit. This is for C chart. In an IC engine. See, casting number and number of defects. Okay, so here the issue in this you have to first find out the sigma C and C bar. So if we add all these values, you will get sigma C. Then total sigma C by Number of values is 10. So 215 by 10, 21.5 is the C bar. Then you have to find out the limit, upper limit and lower limit. C bar plus 3 sigma 3 root of C bar and here minus. So then you will get the two values 35.410 and 7.589. Okay. So here also you have to mark upper limit and lower limit. And here you have to show all the points 20, 19, first value 20, second value 19, then 35, third value 35. Okay, so like that you have to mark all the points. Here also you have to take the sample number on x-axis and the remaining values, number of defects on y-axis. Like that you have to do the procedure. Here also you have to check whether all the points are within the limit or not. This is the process. Okay, right. Thank you. Like that you have to solve the problems. Right.